Hi everyone, back to math today. We're going to review the difference between factors and multiples. These factors and multiples often get mixed up, especially when it comes to bringing them into using them for fractions or finding common denominators or greatest common multiples. So I just want to make sure that we know the full difference. So factors, when we think about factors, those are the factors. I feel like they're smaller. So if we think about the factors as the numbers we use to multiply, so let's add this as numbers used to multiply. Let's keep it nice and simple that way. For instance, if we were to look at something like 3 times 2 equals 6, our factors here are going to be 3 and 2. Okay? I like to think about factors, or I like to show factors in what I call a factor rainbow. So factor rainbow helps me to understand or to remember that factors often come in pairs. So if I remember that factors often come in pairs, I put it into a little rainbow. This makes me remind myself that factors are smaller. So let's take a number like 24. Okay, so actually let's put our 24 down here in the middle. And we have to think to ourselves, what factors can we use to get to 24? To equal 24 when we multiply? Well, 24 I know is an even number. So a couple factors I know are 2 and what? So 2 times what equals 24? We're going to hear 2 times 12, right? So let's take this here. I'm going to plan this out here. So if I make a little, start my rainbow here, and I add a 2 and a 12, I know that these are factors that are equal to 24, okay? Makes me think of the obvious answer I completely forgot to put in here. I'm going to add an extra part to my rainbow. That's why I started here. A 1 and 24. So 1 times 24 equals 24, 2 times 12 equals 24. So we have definitely some factors here. Can you think of another one? Does anybody else think of another one? So 24, 1, 2, 3. Is there anything that multiplies by 3 to get to a factor? Anybody have an idea about a 3? 3 times, let's do it, because I know that 3 is a factor of 24. Let's add 3 in here. 3 times 8 is 24. So 3 times 8 is 24, and so those are 2 more factors, okay? Oh, I feel like there's more. As a matter of fact, I know there's more. So let's add another part to our rainbow in here. And I have here 4 times what? 6. You said it. Well, if you said it, good for you. Okay? A factor rainbow is great because it helps me to know when I have all my factors and when I can stop. For instance, if I put them in order like I did here, I know that I have a factor of 1 times 24 and 2 times 12, 3 times 8, 4 times 6. The only thing I can add in or go further with is 5, and I know that 5 is not a factor of 24 because there is nothing that I can multiply by 5 to get to 24. And then I move it all the way over to 6, and 6 is already on this side. So this is a good indicator that I have found all my factors of 24. So when it comes to factors, think factor rainbow, okay? And if you remember or can create your own factor rainbow, many times you're going to find all the factors of a number that you need, all right? With that in mind, let's move on to multiples. So multiples is what we get, is the result. So the numbers that we land on, let's say when you skip count. So we could say multiples are, in a sense, they're products, okay? So let's add here, multiples are the products. All right, they're the result of a multiplication expression. Multiplication expression. All right. Multiples are what we hear when we skip count. So when we learn how to skip count, way back when we're little, these are the multiples that we have. So if we think about this, there's another good way to remember this is a multiple monster. And a multiple monster is something that's big. He likes to eat. A monster comes in and he wants big things. You know, he wants a lot of something. So if we think about our multiple monster is something that makes numbers bigger. All right, our monster makes numbers bigger. So, for instance, if I were to look at, let's get an example here. Let's do multiples. Let's go with multiples of 7. What are the multiples of 7? So if we are looking at the multiples of 7, we know that our multiple monster here makes numbers bigger. And we know that we hit all of our multiples on skip counting. Can kind of say that when we do that, they're kind of endless. Because when we skip count, really can go on and on forever, right? So let's list the multiples of 7. So if we were going to list multiples of 7, let's take a look here. Let me find another color here. Multiples of 7. Well, 7. What comes next? 14. What comes next? So this is, in a sense, 7 times 1, 7 times 2. What's 7 times 3? 21. What's 7 times 4? 28. 7 times 5, 35, and so on. So we can go on and on and on. So when we list these, we think about those expressions. This is 7 times 1. This is 7 times 2. We have 7 times 3, 7 times 4, 7 times 5. You know, is 49, for instance, a multiple? Yes, because 7 times 7 is multiple. 7 times 7 is 49. So 49 would be a multiple of 7. So factors, think small. I like to think factors, think small. Multiples, think big. Okay? Factor rainbow, multiple monster. You got it.